Hey you guys, I'm going to read your Earth Science review book assignment for days 19 and 20, pages 133 to 135. While I'm reading, you'll notice that I'm making some text annotations and highlighting important information. General circulation of the air in the troposphere. Differences in air temperature and pressure in various portions of the troposphere cause air to be in constant motion. This circulation of air produces convection cells throughout the troposphere. Convection cells. The unequal distribution of insulation on Earth results in unequal heating and differences in air pressure. Cooler air, being denser, sinks toward Earth under the influence of gravity, causing the less dense, warmer air to rise. The result is a series of convection cells around Earth at various latitudes, as shown in Figure 7.8. As indicated by the solid arrows, there are upward currents in the velocity of 0-degree latitude, the equator, and 60 degrees north and south latitudes. Downward currents exist near 30 degrees and 90 degrees north and south latitudes. Regions where air comes together to form vertical currents are regions of convergence. Regions where air spreads out from the vertical currents are regions of divergence. As part of these tropospheric convection cells, there are bands of easterly moving air at the top of the troposphere, called jet streams. The winds of the jet stream can blow 200 miles an hour or more. Commercial airplanes flying with the jet stream can save a half hour of flight time traveling from west to east coast of continuous United States, or lose an hour going in the other direction if the jet stream is not avoided. The jet streams have an important influence on the formation and direction of weather pattern movement in mid-latitude regions such as the United States. The jet streams help steer the air masses and low air pressure centers. The locations of the jet streams are shown in Figure 7.8 on the planetary wind and moisture belts in the troposphere in the Earth Science reference tables. Planetary wind and pressure belts. At Earth's surface, winds blow horizontally, away from regions of divergence and high air pressure, and toward regions of convergence at low air pressure. Figure 7.8 shows the air pressure belts of Earth with generally consistent high or low air pressure. Because of the Coriolis effect, winds moving away from high air pressure are deflected to the right in the northern hemisphere and to the left in the southern hemisphere, as indicated by the dashed arrows in Figure 7.7. The result is a series of planetary wind belts within which the winds move generally in a specific direction much of the time. Thus, they are prevailing winds. Seasonal shifting of the wind and pressure belts. Because the vertical rays of the sun shift north and south with the seasons, the pressure belts and the resulting wind belts generally follow the vertical rays of the sun. So I'm just going to write over here, pressure belts, typically vertical. This results in many parts of Earth being under the influence of different wind and or pressure belts in different seasons. Difference in air pressure and or pressure belts in different and prevailing winds can often mean quite different weather conditions. As an example, in the winter, northern portions of the contiguous United States often get cold weather conditions from Canada caused by northerly prevailing winds. These same regions in summer usually get more southerly winds of the prevailing southwesterlies and warmer weather conditions. In some regions of Earth, there are regular and extreme weather changes caused by the shifting wind and pressure belts. These extreme weather changes are called the monsoons. Figure 7.9 show the changing monsoon conditions of part of Asia around India. Note that the wind that brings the rain blows from the high pressure area over the ocean to the low pressure area over land. Weather movement in the contiguous United States. Much of the contiguous United States is affected by planetary winds that blow from southwest to northeast, called the prevailing southwesterly winds. Therefore, weather changes in the United States move generally from southwesterly direction to northeasterly direction. Formation of surface ocean currents. Surface ocean currents are caused by wind blowing over the oceans and transferring energy to the water. The direction of these currents is affected by the direction of the planetary winds. Compare the map surface ocean currents to the diagram planetary winds and moisture belts in the troposphere in the Earth Science reference tables, as well as figure 710. The directions of the surface ocean currents are also affected by blocking by land masses and the rotation of Earth through the Coriolis effect. Note that the maps of the surface ocean currents show that they are often part of a circular pattern that spins clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. This difference in spinning direction is caused by the Coriolis effect's deflection to the right in the northern hemisphere and to the left in the southern hemisphere. Since the surface ocean currents are a direct result of the transfer of energy from the movement of the prevailing winds, they can seasonally shift their positions. Some of the surface ocean currents shift position north and south as the winds of the prevailing wind belt do, following the motions of the vertical rays of the sun. Review questions. 25. Planetary winds do not blow directly north or south because of the Coriolis effect, gravitational force, magnetic force, or Earth's revolution. 26. On a certain day in Syracuse, New York, there is a high pressure center directly north and a low pressure center directly south. Because of the effect of the Earth's rotation, the air in Syracuse will blow directly to the south, blow directly to the north, be deflected toward the southwest, be deflected toward the northeast. To answer question 27 through 31, refer to the following diagram, which shows the movement of air in the lower part of the atmosphere around the time of an equinox. 27. The movement of air from 1 to 2 to 3 to 4 to 1 would be called a high pressure cell, contiguous cell, convection cell, or Coriolis cell. 28. What is the basic underlying reason for the movement of air shown? Differences in gravity, differences in air density, differences in pressure gradient, or differences in magnetism. 29. What would be the most likely cause of the movement of air pressure at position 1? Low moisture content and low temperature, high moisture content and high temperature, low moisture content and high temperature, or high moisture content and low temperature. Number 30. The air moves at the surface of Earth from position A to position B because positions A and B have low pressure. Positions A and B have high pressure. Position A has low pressure and position B has high pressure. Or position A has high pressure and position B has low pressure. 31. Condensation would most likely occur at position 3, 4, 6, or 7. Number 32. Pilots flying from the west coast of the United States to New York may sometimes shorten their flight time by using a high-speed tailwind. They are most likely using the 1. Prevailing northwesterlies, 2. Jet stream, 3. Convection cells, or 4. Prevailing southeasterlies. Number 33. Which diagram shows the usual path of low-pressure storm centers as they pass across the United States? Number 34. What is the primary source of energy for ocean currents and waves? The moon, the atmosphere, the continents, or the sun? And question 35. What is the most direct cause of major surface ocean currents? 1. Prevailing winds, 2. Gravity, 3. Tides, or 4. Salinity differences.